All right, so we're going to conclude our talk about conics by looking at how to graph conics when the center is not at the origin. So we're going to allow the conics that we looked at to move to the left, to the right, or up or down. And this is something that you have seen previously with transformations of functions in chapter 2. So if I'm moving a graph to the left or to the right, that means that the x is going to change. So if I have a graph and I'm moving it to the left, the y value stays the same. It's the x that is going to change. Similarly, if I'm moving a graph up or down, the x value stays the same, but the y changes. So we're first going to look at parabolas. So if you remember from last time, the equation for a parabola, it's x squared equals 4py. And depending on p, if p was positive, the parabola was opening up. If p was negative, the parabola was opening down. And then also, we had another version of it when the y was squared. Y squared equals 4px. And if p was positive, the parabola opened to the right. And if p was negative, the parabola opened to the left. So in the case, for example, in here, when you moved h units, you moved it to the right and then up, right? The focus changed from being at the value 0p. The focus changed, so the focus is now at the x-coordinate as the vertex, so the x-coordinate is h, and then the y-coordinate of it is p above the vertex. So it's going to be the y-coordinate of the vertex, k, plus p. And then the directress is going to be, let's see, that this is p and this is p. The directress now is p units below the vertex. So the directress is going to be here. It's a horizontal line, y equals, it's going to be k minus p. So you look at your vertex and it's going to be p units below the vertex. So similarly, when you have a y squared equals 4px, the focus is going to be here and the directress here. And the directress is x equals. And then it's going to be whatever the coordinate of the vertex is minus plus p. So h minus p, sorry. You're moving it. And then the focus is here, which is the x-coordinate is the vertex plus p, so h plus p. All right, so let's just look at an example, well, quite a few examples. So let's determine the vertex, focus, and directress and sketch the graph of this parabola. So notice that this parabola without any shift would be x squared equals 8y. But we have moved it to the left and up 2 units. All right, so let's see this. So in general, the equation is going to be x minus h squared equals 4p times y minus k. So in our case, I can see that the h is 2, and then that the 4p is 8, and that the k is minus 2, because y minus negative 2 will give you y plus 2, and that will give us that k is negative 2. So we get that the vertex moved from the origin to hk, And in our case, h is 2 and k is -2. So we have the vertex. The vertex is at 2, 1, 2 for x and -2 for y. So this is the vertex. Two, -2. So it moved to the right 2 units and down 2 units, sorry. Yes. Okay, so now since p, let's see what is p. So I have that 4p has to be equal to 8, so 4p equals 8, so that means that p equals 2. So p equals 2 is positive, that means that my parabola is going to open up. So it's going to be something like this. And this is the vertex. And now where is the focus going to be? And where is the directrix going to be? So the focus is going to be, since p is 2, the focus is going to be p equals 2 units above the vertex. So the focus f is going to be 2 units above the vertex, so 1, 2, so it's going to be right here on the x-axis. So the focus has the same x-coordinate as the vertex, 2, but the y changed because we moved it up 2 units. So -2 plus 2 is 0. And then the directrix is p equals 2 units below the vertex. So the directrix is going to be, you take your vertex and it's going to be 2 units below the vertex. So it's going to be this horizontal line and it's y equals -4. So it's -2, 2 units below -2 is going to give you y equals -4. And I'm writing with the wrong thing. All right, so let's see the next example. So now I have y plus 1 squared equals 32x minus 2. So this is of the form y minus k squared equals 34p times x minus h. So this is of this type, and we'll find if p is positive or negative. So this is going to be a parabola opening to the left or to the right because the y is the term that is squared. So notice that I have y plus 1 squared, so I can write that as y minus -1 squared equals 32 times x minus 2. So this gives me that h is 2, and then k is -1. And then 4p has to be equal to 32. So this gives us that p is 8. There you go. So I have that p is 8. hk, which is the vertex, is 2, -1. So vertex 2, -1. So let's start drawing it. So 2, -1. It's right here. This is the vertex. 2, -1. Then this is a parabola that is going to open to the right because p is positive. So when p is positive, the parabola opens to the right. So you take the vertex and it opens to the right, so it's going to look like that. And then where is the focus? The focus is going to be p units to the right of the vertex. So 8 units to the right of the vertex is going to be, so 1, 2, 3, 4, 5, 6, 7, 8. So the focus is going to be right here. So I add I add 8 to the x coordinate because it moves to the right. So it's going to be 2 plus 8, which is 10, and then the y stays the same. So this is the focus. So it's 2 plus p, and then the y value stays the same. So 10, negative 1. And then the directress is 8 units to the left of the vertex. So it's going to be, I'm just going to put it here. 8 units away from the vector means, from the vertex means 2 directress. 2 minus 8, so minus 6. So it's a vertical line that goes through negative 6. So this is the directress, and this is the focus. So the goal is to find the vertices and then find P, and the focus is going to be P units away to the right of the vertex, and the directress is going to be P units away to the left of the vertex. What if we have something that is given in this form? So it's not given in the form x minus h squared equals 4p y minus k. So, but I have the x squared, and I have all the ingredients in there. They're just not in the right form. So if you recall, when we dealt with parabolas from algebraic point of view, we had that we can write a parabola as ax squared plus bx plus c, or we can write it in vertex form, which was a times x minus h squared plus k. So to get it in that form, we have to complete the square. So what does it mean to complete the square? So if I have just a portion of a trinomial, so I'm missing the c portion, I just have x squared plus bx. So I have the x squared term and the x term. And I want to rewrite it in the form, what we call a perfect square, which means I have to write it as x plus something quantity squared and then plus something else. So in order to do that, we must take half of the coefficient of x. So you're looking at your x coefficient, which is b in this case. Take half of it, and then square it and add it and subtract it to what you had before. So let's look at an example. I know that can be a lot to say. So for example, if I have x squared plus 2x, I want to complete the square, so I want to write it as x plus something, everything squared, plus something else. So if I have x squared plus 2x, how am I going to complete the square? I'm going to take the coefficient of x, which is 2. I'm going to take the coefficient of x, which is 2. I'm going to half it, so I'm going to divide it by 2. And then I'm going to square it. And then if I added this quantity, I need to also subtract it so that I don't change what I'm working with. So then x plus 2x, x squared plus 2x, 2 plus 2, 2 divided by 2 is 1, 1 squared is 1. So I added 1 and subtracted 1. So adding 1 and subtracting 1, it's like adding 0. So it's like not changing it. And then we will combine the first 3 terms together to form a perfect square. What does that mean? It means that I can rewrite this is called a trinomial because it has 3 terms, as x plus what was half of my b. Half of my b is 2, so half of it was 1, plus 1 squared. So this factors into this, and this is called a perfect square. And then I still have the negative 1. So this is what we did. We took this and we rewrote it as this. And you'll see why this helps us. So anytime you want to complete the square, you look at the coefficient of x, you take half of it and you square it, and then you add that quantity and subtract it at the same time. Then the first 3 terms combined together are going to form a perfect squared. And the perfect squared is given by a plus half of the b, everything squared. So let's see the problem we had previously. So notice that I have x squared minus 4x, but I would like it to be in something like this, in this form, because then I can easily see what is the x coordinate of the vertex if it's written like that. If it's written like this, I can't. So let's complete the square. So I have x squared minus 4x. So I'm going to take half of the coefficient of x, so it's going to be plus negative 4 is the coefficient of x. I'm going to take half of it, so divided by 2, and then I'm going to square it. And then I'm going to add it and subtract it at the same time. So let's rewrite this. So x squared minus 4x. Negative 4 over 2 is positive. Negative 2 squared is 4. And then this one is minus 4. So I basically added and subtracted negative 4, and that doesn't change anything. But now I can group these three terms together, and this is going to give me a perfect square. And it's going to be x, because I have a minus in here, it's going to be minus. And then what was half of the coefficient of x? It was 2. So x minus 2 squared. So x squared minus 4x plus 4 is x minus 2 squared. And then I still have the negative 4. So then instead of x squared minus 4x, I have this whole thing. X minus 2, everything squared equals 4. And everything was equal to 8y minus 28. So now if I compare these two, I have the x minus h squared. I have this 4 right here, but I can add it to both sides and get rid of it. So then on the left-hand side, I'll have x minus 2 squared equals 8y. Negative 28 plus 4 is negative 24. So it's almost in this form. The only thing I have to do is factor such that the y is by itself, has coefficient 1. So I need to factor out an 8. So finally doing that, I get it's 8 times y minus 3. So then comparing this with x minus h squared equals 4p y minus k, I can tell right away that h is 2, 8 equals 4p, and then k is 3. So with those values, so I said that h is 2. So h is 2 gives me 2, and k is 3. So that gives me the vertex. Okay, so let's graph it now. So we're going to graph it. The vertex is at 2, 3, so 2 for x, 3 for y. So this is the vertex, 2, 3. And then this is of the type x squared, right? The x squared term, the x term is squared. So it's going to be of this type. And let's see what p is, whether it opens up or down. Well, I have that 4p equals 8. So that means that p equals 2, which is greater than 0, so it's going to open up. So it's going to open up. I did not. Okay, I fixed it. It opens up. And now we just got to find the focus and the directress. So remember, the focus, in this case, is going to be p units above the vertex, and p is 2. So I'm going to add, so it's going to be 2 units above the vertex. So f is, the x-coordinate stays the same because I didn't move it to the left or to the right. So it's going to be 2. And the 3, I added 2 units, so 2, 5 is the focus. And then the directress is 2 units below the vertex. So 1, 2. So this is going to be the directress. Y equals, well, the y right here was 3, and I subtracted 2, so y equals 1 is the directress. Alright, so this one was given in a different form. It wasn't already factored out nicely as these ones, so we needed to do a little more work by completing the square in x. Once we completed the square in x, we brought it in the form that we need. And then we were able to get the answer. Alright, let's do one more example. So this time we're going to, well, the y squared is, the y term is squared, so I'm going to choose to bring it in the form y minus k squared equals 4px minus k. x minus h, sorry. So it's going to be something like this, either opening to the right or to the left. So I'm going to combine all the terms in y on the left-hand side. So it's going to be y squared minus 4y equals add 15x and subtract 34. And then I'm going to complete the square in y. So I'm going to take half of the coefficient of b and squared. So negative 4 divided by 2, half of it is 2, and squared, that means 4, and then I'm going to subtract it as well. And then these three terms are going to combine into y minus, before I squared it, it was 2. So y minus 2 squared. And then I'm going to add this negative 4 to both sides. I'm sorry, this was a 15x. So it's going to be 15x, negative 34 plus 4 is going to be negative 30. So this is almost in the form that I needed. The only thing is that I need to have x minus h, so I need to factor out 15. So y minus 2 squared equals 15x minus 2. So now comparing these two, I can see that the k is 2, because y minus 2 is at y minus k. And then the h is 2 as well. So the vertex is going to be at 2, 2. And then I need to have that 4p equals 15. So 4p equals 15 gives me that p is 15 over 4, which is 3.75. Which is greater than 0, so that means that the parabola is going to open to right. Opens right. Okay, so now I have all the information in order to graph it. So I'm going to plot the vertex first. 2, 2, 1, 2, 1, 2. So this is 2, 2, the vertex. And then I know that it opens to the right, so I'm going to draw the parabola. And then I know that the focus is going to be p units away to the right of the vertex. So it's going to be, let's say here, the focus is, so the x changed by p. So it's going to be 2 plus 3.75. The y stayed the same. So the focus is 5.75 and then 2. And then the directress is going to be p units to the left of the vertex. So it's going to be right here, let's say. So the x was 2, and I subtracted 3.75 p. So it's going to be x equals negative 1.75. It's the horizontal line. So this was 2. I subtracted 3.75, so I got the directress.